is about solving quadratic equations. We've got a few methods that we're going to go over. Some quadratic equations can be solved using square roots. These are the easier ones. So pretty much anytime you've got x squared in the equation with no x, then you can solve it using square roots, like these first two examples. So the first one has an x squared without an x term. I can add the 7 to the other side and just solve this like you would normally solve an equation by getting x by itself. At this step, to get rid of the second power, we need to use a square root. You just have to remember to always put a plus or minus sign in front of your square root, because a square root could be positive or it could be negative. So plus or minus the square root of 7, and I don't want you to take out a calculator and get a decimal for this, so we can just leave it like that in simplest radical form. There are two answers anytime you have an x squared equation. In this case, it's one positive and one negative, though it's not always that way. In the next one, we're going to subtract 1 first. So 4x to the second power equals 9. I'm going to divide by the 4, so x squared equals 9 over 4. And then I can square root both sides. So x is going to equal plus or minus. Always put a plus or minus in front of your square root. 9 over 4. Underneath the square root symbol. And if you can square root them, then you should. You can get it to be a whole number by doing it mentally. So x is going to equal plus or minus the square root of 9 is 3, and the square root of 4 is 2. And so our final answers are positive 3 over 2 and negative 3 over 2. In the cases like these bottom two examples, your temptation is going to be to write it out and FOIL it, which you can do, but you create a little more work for yourself that way. If it's written like this in parentheses with the exponent outside, you can continue using square roots to solve. So if I were to add this 4 to the other side first, it would be equals 29. So I've now isolated my expression that has the exponent on it. And now I can square root both sides. And when I do, the squared and the square root will cancel out. Don't forget to put the plus or minus on this side in front of your answer. And x minus 2 is going to equal plus or minus the square root of 29. I'm going to consider this to be two separate equations because I'm not done yet. So x minus 2 equals positive root 29, or x minus 2 equals negative root 29, because you need to get us two answers to this. My final step is going to be to add 2. So positive 2 plus root 29, or in this case, positive 2 minus root 29. You usually will see your rational number before your irrational number like that. So your two answers are 2 plus root 29 and 2 minus root 29. And then in this last one, I'm going to divide by 3 first, because I do need to get this expression by itself. And the reason I'm showing this one is because when you square root an 8, don't forget to put your plus or minus in front of it. On this side, the square will cancel out. If you can't take the square root, but you can simplify it, then you should do that. So I hope you remember simplest radical form. It involves splitting 8 into 2 pieces, one of which you can do the square root of in your head. So I chose 4 and 2 because I could do the square root of 4 in my head. So this is going to simplify into plus or minus 2 radical 2, because the square root of 4 is 2. And then I'm going to subtract 1, so it'll be negative 1, plus or minus 2 root 2. I could have written it twice and solved it like I just did in the previous example, but you'll often see it represented this way, as 2 separate answers, but with the plus or minus built in to show that you've got 2 answers without having to write it twice. And then there are some cases when you have the x squared and the x in the same equation that require factoring in order to solve for x. So if I was to try to get x by itself in either one of these, I'm not going to be able to, because I've got it in 2 places. I've got it in the x squared term and I have it in the x term. And I can't combine those to get x to be in only one place. So this is when you have to use factoring. This is why we learn factoring, so we can solve equations like this. In the first one, the only type of factoring I can do is take out the greatest thing you can take out. It already says equals 0. Everything's together on the left side. All I can do is take out a 5x. And what will be left is 2x plus 1. Always remember to put your plus 1 when you're taking out itself. In a multiplication problem that equals 0, which is what we have here, right? 5x multiplied by 2x plus 1 equals 0. Then either the 5x must be 0 or the 2x plus 1 must be 0. Because when you multiply two things together and it equals 0, it's pretty obvious that one of them has to be 0. So the zero product property is what I just described, that one of the two things, or both, have to equal 0 in order for the equation to equal 0. So what you can do is write this as two separate equations. Remember, we're looking for two answers. The first one equals 0, or the second one equals 0. And these are both just linear equations that you can solve. So divide both sides by 5, and 0 divided by 5 is 0. It's one of our answers. Subtract 1, divide by 2, and x equals -1/2. That's our other answer. So two completely different answers. In this next example, it says equals 28. So I can't use the zero product property when it says equals 28. I need it to say equals 0. So my first step is to get it to say equals 0. See if I can factor the left side of this equation. When there's nothing in front of the x squared, I can start right away by filling in the parentheses. Splitting up the x, what makes -28, that adds up to +3. I'm going to use +7 and -4. And now I have two factors, right? This is a multiplication problem equaling 0. So I can set up either this factor equals 0 or this factor equals 0. And then solve. Subtract 7. That's one of the answers. Add 4. That's the other answer. So always looking for our two answers to quadratics. Don't forget splitting the middle term factoring. It's an important method. It's going to come up again and again. If you have to factor something like this, start by multiplying your two outer terms together. You're looking for what makes -30 that adds up to the middle term of -13x. And I'm going to choose -15x and +2x. And bring down the other terms around it. So you've now got 4 terms in a row. Factor something out from here. It's going to be a 5x, which will leave us with 2x - 3. You have to factor something out from the second set. And since there's really nothing that comes out, we're taking out a +1, which won't change the 2x - 3 at all. 2x - 3 has shown up twice, so we only need to write it once. We take it out. What's left is 5x + 1. And now finally I have a factored problem, so a multiplication problem that equals 0. And I can write each factor as a separate equation. And they're linear equations that I can solve just by adding, subtracting, and multiplying and dividing. X is going to equal 3 over 2. And in this case, 5x equals -1. So x equals -1 divided by 5. Two answers, just like I was expecting. I'm going to forewarn you that often when you see an equation like this, you think, oh, I can just divide both sides by x, and that's how I'm going to get my x by itself. But it's only when it looks like this that you feel tempted to do that. It is illegal to divide by x and cancel it out here. It's considered illegal in math because we don't know what x is right now. And we don't know if x is 0 or not. And remember that when something is 0, you can't divide by 0. So if x is 0, you've just created an undefined problem. And you don't want to create an undefined problem. So it is illegal to divide by x when you don't know what it is. So what would the correct way to solve an equation like this be? You want to get it on one side by subtracting the 3x, the entire term, and have it say equals 0. Then, remember when you have x squared and x in the same problem, you're going to have to use factoring. So the only thing we can do is factor out an x, or undistribute that x. And then we have two terms that can both get set equal to 0. X equals 0, x - 3 equals 0, and this one's already solved. This one we have to add 3 to solve. So there's our two solutions. And sure enough, x equals 0 is one of the answers. And therefore, it would have been illegal for us to divide by it in the beginning, and we would have only gotten one of the solutions. Sometimes, it doesn't look quadratic right now, nothing is squared, but sometimes it's going to become quadratic after you apply another method, like in this case, cross multiplying. So you know when you see two fractions with an equal sign between them, you can cross multiply the numerator of one times the denominator of the other with an equal sign in between the numerator of one times the denominator of the other. This is how it ends up being quadratic, because on the left side you have to distribute. It's going to be 2x squared plus 4x. Distribute the 1 over here. Now we've got x's, we've got x squared, all in the same equations. We have to get everything on one side and make it say equals 0. So I'm going to subtract 3x from the 4x, which will just say plus x. I'm going to subtract 1, and now it says equals 0. I've got no choice but to factor when I have x squared and x in the same problem. I'll use splitting the middle term here because I've got a number in front. So what multiplies to -2 that adds up to positive x is going to be 2x minus 1x. Bring down the first and the last term, and then factor by grouping. So I can take a 2x out of here, which will leave me with x plus 1. I take a -1 out of here, which will leave me also with x plus 1. Our two factors are therefore x plus 1, which can come out, and 2x minus 1. And now I have a factored problem that equals 0, so I can set each factor equal to 0 and solve for x. We have x equaling -1 and x equaling 1/2. And then the final example we need to go over is we've got a factored problem, but it doesn't equal 0. This is an annoying problem more than anything. It's already factored, so you're thinking that work has been done for you. But because it doesn't say equals 0, you're going to have to expand it, which means use FOIL, then refactor it in the end once you get it to say equals 0. So if I tried to subtract the 8x right now to make it say equals 0, there's nothing I can subtract it from on the other side. The other side hasn't been simplified yet. So we got to simplify the left side first by expanding this using FOIL. Then you can subtract the 8x, because now I've got a term I can subtract it from, and it actually cancels out on both sides. We're left with x squared minus 9 equals 0. This is one of those cases there where we can use a square root, remember way back to the first slide, because I have only x squared in this and I don't have an x term. So in this case, I can set up x squared equals positive 9, and just don't forget to use the plus or minus when you use the square root so that you get your two answers. Square root of 9 is something we can do mentally to get a whole number. So our answers are positive 3 and negative 3. And that is all.